Hi, Mike Matchett with Small World Big Data. We are here talking to one of the brightest stars in the storage space, and that's Quobyte. We're talking about really hyperscale storage that almost anybody can deploy with just a few commands and get going. It's really some interesting features in there. I've got Bjorn Kolbeck here today. Welcome, Bjorn.
Hey, Mike, good to be here.
All right, so Bjorn, tell us what your role is at Quobyte and how you kind of got started with this, and how you got inspired to create another storage system.
Sure. I'm one of the co-founders, and I started Quobyte together with Felix Hupfeld, and both of us started our career in high-performance computing. So we worked at a supercomputing center, and we saw how you basically run very large infrastructures. And after finishing our PhDs, both of us worked for Google, and that was a very different experience, also very large infrastructures. But I think what Google figured out, where everyone is still trying to replicate that, is how to manage those very large infrastructures with tiny teams. So really make the operation scalable. If you know HPC, high performance computing, you know the joke. You have an army of PhDs to run, faster file system or a supercomputer. In commercial settings, you can't afford that, and Google really cracked that problem. And that's why we started Quobyte, to bring those two worlds together. On the one hand, you know, serve scale out workloads that are very demanding and that have moved into the enterprise today, and bring the Google style operations, the massive scalability on the operational side, into our product. And that's Quobyte today.
So if you bring this kind of storage, this high performance quality storage, down to the fact that we don't need that army of PhDs, what are they going to go do? I'm just teasing you. You're going to put
Yeah,
all
if
these
you work
storage PhDs out of work.
yeah, if you work in IT, you usually have more work than you have time in a day. So if you can make storage less of a task, less of a time-consuming thing, I think everyone wins.
All right, so I think people who are watching this are probably now curious as to what Quobyte is made up of. So let's lift the hood a little bit. It's a software storage system, right? So some people might call that software defined or whatever else, but it's basically something that will run on pretty much any server you bring it to, right?
Yeah, that's why we call it real software storage, because you can actually download it, install it on any x86 server, and turn it into a storage system. So we believe that the power of software, or why everyone loves software, is the ability that you can just download it, install it, and then you have a running storage system instead of going with appliances that need to be racked and stacked. So you're talking about weeks and actually shipping physical hardware. But here, you can download Quobyte and install it yourself, and you have a working storage system that's highly scalable, reliable, has the security features, and you have that in minutes.
All right, because it's a scale out system and you've done all this great clustering, you can put it on any hardware, even hardware that's not completely certified to the nth degree, like some of the other guys might want to do. You can run this even in clouds, right? You can run this on cloud instances and create petabyte size clusters.
Exactly. We don't certify hardware. We recommend hardware, but you can use whatever you prefer. And because we're 100% software, we also run on the public clouds, and you can go wherever your workloads need to be, or whatever you decide works for you best, and then move between the cloud and back on-prem. Kubernetes gives you the same environment.
All right, so we're gonna I know we're gonna touch on performance before we finish this discussion because that's one of the key things here. But let's stick on infrastructure for a little bit more. So, if I bring in nodes that have disk drives in them, you'll use whatever storage is there ostensibly. But what if I mix flash and hard drives? Do you guys create tiers or do you use one or the other? How do you have customers set that up?
You can use both at the same time with Quobyte, and not just as tiers. I mean, that's a traditional way, and
Mm.
our software can also tier between the two. But we can also combine the two storage media inside the same file. We call that auto layout, and that solves the problems you have when you have a mix of tiny files and large files in the same file system. Because whether it's machine learning or life science workloads, you typically have this mix. Sometimes you don't even know. And we solve that by automatically switching between the two, even inside a file as it grows, and give you the best price and performance through this combination.
So I think this is fascinating. So if I have lots of small files and they fit in the flash layer that I have or the flash disk, you put them there. As the files grow bigger, I can start in flash and that file will extend out as it grows bigger into the hard drive space within the file itself. And now let's touch on performance a little bit. How does that help me on performance if it's just partially in flash and partially in the hard drive?
Yeah, for this example, if the first part of the file is in Flash and that basically solves the latency problem, so the first access to the file will be very fast, and then in the background we start to load the data from multiple hard drives up to I think 15, 16 hard drives in parallel,
Okay.
stream the file. So basically, the time to first byte is reduced to Flash, and then we stream from several hard drives, and this is how you get up to 2 GB per second on a single file from hard drives.
All right, so you just get this fire hose of information, and to speed that time to first byte, you can layer the flash in there on the first part of the file, which is very clever, and that happens automatically, right? You can set that up on a basis into this, which is
Yeah.
cool. And can I adjust my policies in where I store things at down to a volume or more granular?
Sure, you can actually adjust it down to the file level. So we have all the nice metadata information because we're a file system like extension, who owns the file, what's the size, what's the last XSH, and so on. And you can use that to define your own policies. So the outer layout makes your life easy, but you can decide that certain users or file types should reside exclusively on Flash, or maybe everything lands on Flash and then goes down to hard drives. So you can decide that down to level and say, okay, Bjorn's MP4 files go to hard drives only because he creates a lot of data and that's annoying for everyone else. You can go to that level.
All right, and again, this installs. You can just get it off the internet. It's pretty easy to download. And does it support containers, containerization? I mean, I'm assuming cloud native. You've got a story there.
Yeah, it's software, real software storage. So we also run in containers, and we have a Helm chart on our website that you can use to deploy the server part on containers on Kubernetes. The client part, we have a CSI plugin, so you basically run your storage system on Kubernetes and deliver storage to Kubernetes. You can do
All
all
right,
of
so
that.
so
Quobyte.
a full Kubernetes support for that storage as well, which is really nice. And I did see something on this that said that if I have the cluster going, it uses some part of your name quorum kinds of voting between the cluster nodes. So you can take out any node here for whatever reason it drops or it fails, or you're doing upgrades to it, and the rest of it still works. How did you architect that?
Yeah, we basically built the system in a way that failures are okay. And it's not just failures, if you want to do things like non-disruptive updates, hardware maintenance, hardware refreshes, adding nodes, removing nodes, all of that without disruption, the system has to be able to tolerate the loss of a node temporarily or permanently. And so we designed the system from the ground up to be okay with that. And the nice benefit of that is that you can do all your admin work, all your maintenance work while the system is running at full speed. So no need for maintenance windows, anything like that.
I think you might have inherited that sort of mindset from Google. That sounds like something a hyperscale cloud provider would want to do, right?
Exactly, because
Yeah.
if you think how difficult it is to coordinate maintenance windows, even in small organizations, because you need to talk to the application owners, to the people in the data center that own the hardware, it's a lot of coordination. If you tried it at a larger scale in an organization like Google or a hyperscaler, it wouldn't work. You couldn't run at that scale. So that's part of how you run your storage efficiently. If you spend too much time on storage, the coordination and maintenance windows, the way you operate your hardware is a big part of this.
All right. And let's just circle back now to performance because we're talking about this. As I scale the system, being a scale out system, how big can I go? And do I maintain a performance linearly with scale, or is there a drop off curve? What can I expect if I'm scaling this?
So we have customers with hundreds of servers in production, and you can easily scale to thousands of Quobyte servers. And it's linear scaling. We built the architecture in a way that doesn't have bottlenecks. Part of that is the quorum algorithms and how we elect leaders that you mentioned earlier. And that allows you to have linear scaling. So when you double number of nodes, you'll have twice the performance, whether you go from 4 to 8 or from 100 to 200, you don't have diminishing returns. So it's true linear scaling.
Which is fascinating. So linear scaling, and I can take nodes on and offline and work on them and upgrade them without disrupting everybody else. This is not RAID, I guess, right? You've got some other kinds of replication going on.
Yeah, we use the quorum replication that you mentioned. So basically synchronous quorum replication for data redundancy or erasure coding. And we can also combine the two for basically best performance and best cost.
Okay, so lots of some tuning knobs. Not that you need a PhD for it, right? But somebody who cares about how much my cloud's costing me might be able to go in there and say, these big workloads go here, these smaller workloads go there, and line them up by what that division or department has budget for. Uh, Licensing, just quickly, there's obviously a free version of this. What does that take us to?
So the free version gives you 150 terabytes of hard drive space and 30 terabytes of SSDs.
Okay.
You can download that from the web and just use it also on the cloud. So that gets you started. It comes with all the features like Kubernetes support, Hadoop plugin, our native driver, and so on. So that gets you started immediately. And this, if you have a small cluster, that should be enough. And then you can use our infrastructure edition with basically unlimited capacity and some of the enterprise features like security and Windows drivers.
All right, so I can get started up to 150 terabytes without cost on there, which it seems big to me, but I know that a lot of your customers really start at a petabyte or more, and this is where they're really digging into it. But I was like, as a file system, that's great. Get that up there. When you have uh, an object in this file system, let's talk a little bit about that. It's a single namespace, I understand, in the same cluster. What kinds of protocols can I go after those objects with?
Yeah, we're one of the few systems where file and object are in the same namespace. So that's two protocols that you can use, like the native Linux driver, Windows or Mac, and then access the file as an object and vice versa. That makes data sharing very easy. And then we also have the Hadoop driver that I mentioned,
Okay.
MPIO for the high performance computing folks, TensorFlow plugin, and they all share the same namespace.
So if the file and the object same namespace, and I can get at that with the same with different protocols, which is pretty cool. Uh, this sounds like you've got some great ways to compete with some of the stodgier, older folks in the industry. And I'm not going to pick any names right now, but one of the research reports we've been looking at, and something where you guys really shined, was in a life sciences study we recently did with DCIG. And let's just talk just briefly about that. The workloads in life sciences are generally large. The workflow requires multi-protocol support, and there could be a large number of small files. So they're either large files or large numbers of small files, and there's, like you said, sometimes an army of PhD people required to go after it. How are you guys doing with life sciences? Do you have folks using it in that way?
We have customers using it, and they particularly love the auto layout because life science is one of those use cases where you have usually a mix of different file sizes. It also depends on the actual application that you have. If you work with genome sequencers, you have a lot of tiny files. Then you often have image files, whether it comes from some imaging technology like microscopes or MRI. Those tend to be larger. Often you have to work with both on the same storage system. So that's why life science customers love the scale out with the ease of the auto layout. And then in life science, you often work with sensitive data because it's medical data. Sometimes it's can identify a person. So security is a big one in this segment as well. So this is where we bring the end-to-end encryption, where we
Okay.
have stronger access control with certificates, TLS connections to make sure that the storage that you have a higher level of storage security than you get with traditional protocols like NFS.
Right, you can even encrypt the data, I understand, so that the storage admins themselves don't see the data. They can only
Yeah.
administer the volumes. So, sounds like some really great security features there as well. And I suppose that would apply also to the, other verticals like finance and some other folks that do healthcare and you know oil and gas and stuff like that.
Yeah. In the end, anyone who has a scale out problem, and then I would say the level to which they need security depends a bit on the sector. So life science is often more conscious about this. Healthcare too. Other sectors like oil and gas, maybe not as much.
Okay, so high performance computing, level storage, cloud level scale out facility, downloadable as software, run on anything you want. Where can I get a copy of this, Bjorn? Or if someone's interested, tell the audience how they can get their hands on it.
Go to our website, quobyte.com. there's a big button in the top right corner for the free edition. Click on it, you copy one command, and that launches the install process. And a few minutes later, you have a working, reliable, scalable Quobyte cluster. That's
And
as
it's
simple as
not millions of dollars in 6 months to acquire and rack into your data center. It's just download and go, and you've got high-end storage, folks. Check it out. Bjorn, thank you for being here today and explaining this to us, and congratulations on that top 5 placement in the DCIG report for Storage for Life Sciences.
Thanks, Mike. Thanks for having me here today.
All right. Thanks, people. Check it out. Download that storage and get it going. Take care.